morning. I am not a morning person, and this class is at 8 o'clock, so I need a loud, resounding good morning. So good morning, everyone. Okay, that was better. That was better. I appreciate that. All right, so this morning, as Dr. Murray talked about, I will be talking about environmental justice. Just to give you a little background as who I am. So we're going to bump into it, but let me give you an overview first. First, we'll give a just personal background really quick. We'll zoom through that. So we're running a little late, but that's okay. We'll get it done. And then I'll give you an activity, and there'll be a couple activities. So I'm really actually glad that you guys are on your Chromebooks or phones or whatever, because I will need some participation. So I've already put one link in the chat. So if you can go ahead and try and open that in a separate window, that would be great because it's coming up. And then I'll give you a brief overview of environmental justice. There'll be some videos for you to watch, so make sure that you can hear me. And then I'll go through how the case study connects back to soil chemistry. All right. And then we'll open it up for any questions. Sounds like a plan?
So we may have to, just to let you know, we may have to shorten different parts of this because we need to get out here by 8:45.
Okay, will do. I have my timer on. So, all right. So just briefly what my background is, which I think always helps students to put in context what I'm saying. I have a bachelor's degree in chemistry with a minor in botany, which is about plant science. And then I have a master's in marine estuarine and environmental sciences with a specialization in environmental chemistry. And then I did my PhD in environmental chemistry and toxicology. And then my postdoctoral fellowship is in environmental health. So then I took the science and blended it with health. All right. So what I want you to quickly do, I do want you to take part in this one. It's a poll everywhere. Click on the link I put in the chat or cut and paste it. And I want you to fill out the question that's on that. And it asks you, environmental justice. When you hear that, what do you think? So it should be active. Just type a word quickly. I don't see any responses yet. All right, having justice, great. What else? Awesome. So this is going to do a word cloud. The more people say a particular word, the larger that word will appear. Awesome. So people, that's good. That's good. Environment, freedom. All right, justice, fix, try, nature. Courtrooms, that's interesting. That's cool. Having, the haves and the have-nots, good. All right, fair, hurt. Fix, that's important too. See, freedom coming up a lot. Environment, justice, people, freedom, and nature are our biggest ones. All right, just a few more seconds. Awesome, guys. Okay, so I want you guys to see for yourselves. Let's stop at this point that justice, environment, people, I'm so glad people's coming out strong. Freedom, fairness. These are some really important aspects of environmental justice. So you guys are rock stars here. Thank you. So let's go back to this presentation. So you guys have a good sense of the key words in environmental justice already. So I'm just going to give an overview of how it now connects back to soil chemistry. All right. So this one is a video that I really want you to watch. We're not going to look for it for the whole duration, but there's a snippet of a key scholar in environmental justice. He too has a degree in chemistry, environmental chemistry, and focuses on community, like you guys talked about, people and fairness. So I'm going to have you watch this video now. All right, I got to do a couple of things. Got it ready. Oh, come on. gosh, I didn't put up Jacoby's. Okay. All right, give me a sec. Where's the video? All right. I'm sorry, I'm the wrong. Oh, that's the wrong one. All right. One sec, guys. Just give me a quick minute. And then we'll be rolling. Come on, come on, come on. All right, here we go. Can you guys hear that?
I'm not hearing it yet.
Area. Here to talk more about it is...
Not yet?
We just heard something. But
oh, this is why. All right, can you guys hear this?
Not
I have to
hearing.
come off my headset. One sec. Not hearing it?
No.
All right, can you hear that?
No.
You should be able to hear now. Speaker. All right, I'm going to stop sharing for a sec and then reshare. All right, so I'm going to share again.
Environmental justice and health disparities.
That's right, Monica. The event will focus on solutions for issues affecting our area. Here to talk more about it is Dr. Jacoby Wilson. Thank you for joining us.
Thank you.
Let's kind of start off about talking a little bit about the event and what it is.
So we have a symposium that we've been trying to do several years at University of Maryland College Park, and the focus is on environmental justice and health issues. For the audience, that's about looking at how some communities, due to race, ethnicity, due to class, due to geography, may be overburdened by environmental hazards and locally unwanted land uses. That could be chemical plants, factories, heavily trafficked roadways. It could be chicken farms in the Eastern Shore. It could be concrete block plants, concrete batching plants. It could be gas-fired facilities. It could be coal-fired power plants. These are all facilities that emit pollutants to the air, water, and soil, and those pollutants can impact human health. In addition, these are communities that may be overburdened by psychosocial stressors, so crime, violence, exposure to discrimination and ism. And then those communities are the same communities that may have lack of access to good infrastructure. So do you have a grocery store in your neighborhood? Do you have a supermarket? Do you have a park? Do you have infrastructure that helps to make your community a healthy ecosystem? So those are the issues that we're focused on at this symposium.
Gotcha.
In an article in the Post, Dr. Wilson, you...
All right. I'm going to stop sharing that. I'm going to go back to the slides. So as I do this, tell me what you heard. I need you guys to spitball it out or put it in the chat. What did you hear? Is there anything else we need to consider in environmental justice? All right, I see one in the chat. Let's see what it says here. Oh, no. Come guys, I need you guys to talk to me. Talk to me. Take your mics off mute and talk to me. What did you hear? Can you hear me, Desmond?
Yeah, I'm hearing you. Any responses?
Right. I see a couple responses. Chicken farm, yes, he talked about the chicken farms. What else? Making sure that the environment is safe, effective place for all. All right, what else? Crime, race and economic status, good, cannot be discriminated against. But what I want you to notice is that it's a part of the equation. Race and economic status, great. Talking about crime. What else? Come, spitball it, a couple more. Environmental justice is about helping people get what they need, and that the environment is helping people do well. That's good. So it combines some of the social factors with environmental factors. Very good. All right, that was very good. You guys are getting a sense here. Asthma attacks from pollution, good. And he talked about things like disenfranchised, so some of the social factors, so the community being disenfranchised or not having grocery stores, not having high crime, like you pointed out. So these are other factors that are basically what we call scaffolding, or one on top of the other. So you've got pollution from environmental sources, then you've got these social problems as well that make it even harder for the community to face the problems that the environment pollution creates. Does that make sense? All right, so great. So environmental justice, adding the freedom of choice. The color of your skin or the thickness of your wallet, meaning more affluent communities, shouldn't determine your ability to breathe clean air. All right, great. You guys are rock stars. Thank you. All right, so we talked about that. So the problem of lead in soils, I'll cut this video out. The problem with lead in soils has been seen in a lot of communities.
So
we're
not seeing your video, your screen now. We still have the video. Okay, there we go. And we need to get your PowerPoint.
Can you see that?
Yeah.
Okay. All right, so we talked about the problem of lead in soils here. This was a community, and at some point I'd like you to take a look at it. I'll share the slides with Dr. Murray. The problem of lead in soils, this one talks about a community in California, but you're going to find the same in a lot of lower income communities, that where there's an older housing stock, where houses were built before 1978, you'll find that there's a lot of lead contamination in their soils, as well as where else. Let's look at lead specifically. Where else do you think lead would come from besides the paint that was used prior to 1978? Where else do you think lead's coming from? Come on, guys, I like interaction, so let's go. All right, let's see here, chat. Fuel, very good. Fossil fuels. Before the 1970s, before it was banned, and I shouldn't say completely banned, there's still a small amount. Building structures, very good. Lead pipes, lead glass, yes, very good. So these sources of lead are predominant when you talk about communities that are nearer roadways, right? You have lower income communities typically in areas where there's a lot of transportation. Yeah, garbage dumps as well. You mean the landfills? Sometimes, yes. If the landfill is not lined, which some of the older landfills aren't, and then the landfills are in locations with lower income communities often, therefore that compounding again, you will find that, lead can enter the environment that way. So you've got the two primary sources are the paint prior to 1978, so old housing stock. So, a lot of these disenfranchised communities live in older communities, and then older communities, meaning they've been around for a long time. So the housing stock is old. And it's not just that housing stock. When there's lower income, they cannot renovate and update and put new coats of paint on there continuously. So the older paint tends to strip off, and that's when the problem starts. Because if it's contained, it's not a risk. But if it's not contained, then it's a problem. And then, of course, living near roadways, you'll have that contamination from fossil fuels, the air pollution. Once it rains or precipitates in any way, it causes the particles in the air to drop down to the soil. And so now the soil is contaminated. So why does this matter? How do we get lead in our bodies from lead that's in soil? Tell me, somebody put it in the chat. How do you think it goes? Because if it's in the soil and we're never interacting with the soil, that's great. But how does it go from the soil to us? Agriculture is one. Good. It does get into lead, has some mobility in plants for uptake for food. Also, you have to consider if you're growing in an urban garden and you don't wash your leafy vegetables well, some residue there. All right, so that's good. How else? In water, you let it pipe. So if it does contaminate the soil, and I'll talk more about this, but if there is something that will transport the soil to the water, and I'll explain why I say that, and it does get into our drinking water, then that's a problem. Now, the lead in Flint is a little different, that the lead was used as pipe soda to join pipes. And when the pH of the water is acidic, it will strip that lead from the soda or the joiner. Now, this is the key piece here. Children playing outside. When dust comes into your home and young children are on the floors, that dust is then taken in. Or if it gets into the air, it is then breathed in. So that's how it goes from soil outside into humans. So you guys talked great. The gardening is a big one of how it gets into our bodies, and then bringing it into the home by tracking it into the home, and then children getting it there. There's a third one where children are, we talked about the old paint stock, but that doesn't deal with soil. So I'm going to deal with the ones you've talked about. Awesome. Awesome. You guys are rocking and rolling. So, okay. So how is all this now related to the chemistry that you're supposed to be learning here? All right. So one of the things to consider is that anything that accumulates in the body has an input, an output, and the output is different from the input based on any reaction that's going on within the body. All right. So accumulation of what goes into the body, let's say the children that you talked about, would be how much dust that contained lead they took in, how much is excreted, and what is going on with that lead inside their bodies will determine how much lead is actually in their blood. So let's stick with lead. All right. Accumulation in, out, and the reactions in there. All right. Great. So I'm going to skip over that. So I'm talking soils today. So what really is soil? People keep calling it dirt, and it's not. So after today, I hope you never call soil dirt. It's not dirt. It's soil, which has a very unique characteristic of itself, right? So it has water in it. It has air. There are particles in it, and those particles we'll talk a little bit more about. There's inorganic particles and organic. And this combination makes up soil. We'll talk a little bit more about what are the organic and the inorganic parts, because that's particularly relevant when we talk about soil lead. All right. So this is what soil looks like. If you were to cut a mountain down or cut down, forgive me for using this reference, but if you were to dig a grave and look on the side, on the inside of the grave, this is what you'll see. The grass on the top, a very dark top, and then a slighter zone, and then, so it's literally in blocks on top of each other, all right? This is what soil looks like, and it starts from sea, because it always starts as rock, and as weather beats on it, and rain falls on it, and acids and anything acidic falls on it, it breaks up and becomes B, and then becomes A, and mixes with grass and other organics and becomes this O layer. All right. So soil really builds from the bottom up. All right. Why am I saying all of this? Because how your contaminant, be it lead or be it polycyclic aromatics or be it benzene, how they behave in the soil is determined by the chemistry of the pollutant and the chemistry of the soil. So if a pollutant goes down into the soil, it's because it's not reacting with the chemistry of the soil, so it moves further down. Lead does not move very much in soil.
because it stays with the organic, and organic is dark. So where is it going to stay? In A, B, or C? Put it in the chat, quick. Lead stays with organics. Organics is the darker portions. So where would lead stay? Let's see here. Awesome. O and A. Very good. Very, very good. You guys are really rock stars. All right. So let's take a little bit more, a closer look at the chemistry of the soils itself. Clays and organic matter. One form of organic matter is humus. Those are the two major players in soil. All right. You've got sand, you've got silt, but these are less reactive than anything else. Clays and humus and or organic matter are the most reactive. So we just talked about that. Now you guys know like goes with like. Clays have a lot of positive and negative charges. And this diagram down here shows you what clay looks like. The reds are silicon. The whites, little balls, are oxygen. And they are bonded together in a matrix, all right? So there's a lot of charge, and clays tend to be layered. So you've got one layer on top of another layer. You see that white space in between? That white space in between, let me get my annotate, 1 second. This white space in between here, that white space there is between the layers of clay, and it's very positive. Positive charges are in there. So things like calcium, magnesium, potassium get stuck inside there. It's attracted to there. Now that's important because your plants need that. So it holds the cations. You guys, I hope I'm using terms you guys know, right? So cations are great. Cations get trapped inside those clay layers, all right? Now you notice there's not a lot of organic there. So organics don't get into there unless, and I'm gonna put a question mark there and we'll see the question mark later, all right? Now, the other things in soil are, we talked about the organics and we'll see it in a minute, things like iron and aluminum oxides. You'll find oxides, which are kind of clays as well. And once you hear oxide, you know oxygen, you know it's going to connect with a positive. Oxygen is negative, iron and aluminum are positive, they cross a bond, and they have certain reactivity as well. All right, so we talked about the clays, and then the humus. The humus has a lot of, and we look at these functional groups, OH and COOH. When we lose the H, what happens? Does that become positive or negative? The O becomes, give me one person, give me in the chat, positive or negative? Lose that oxygen and the hydrogen, and it'll become negative. Awesome, negative, all right? So we do see some charge going on in the organic matter, but most of it is chains of carbon. And we know chains of carbon create an organic, right? So it's oils or hydrocarbons, all right? So what does that mean for our lead? Come on. Right. All right. Didn't realize it'll transfer. So this is what humus looks like. Well, to the best that people can establish. It's not often really understood. So what I want you to see here are a couple things. See these long chains of cyclic aromatics? That makes it very organic. Once oils, things that will trap in oil. But what I want you to notice, it also has on its external things that can give it positivity or negativity. Well, sorry, would attract positivity, all right? That's important where your lead is concerned. This is where your lead gets trapped, all right? because lead is so much larger than the calcium and the potassium that we talked about earlier, it doesn't fit with the clays. It's too large to go into that space. So it tends to associate more with the organic matter and stay in the A layer. Now, why is that relevant? You talked about kids in their yards, and then they come inside, they bring that soil inside. They tend to take it in when they crawl on the floor, right? So it gets trapped in the top layers of soil, so it's more accessible to us. So we're more likely to get exposed to it, all right? We talked about dual functionality, the functions in the soil and the functionality of the chemical and how they interact. So some chemicals here you see, there's a different categories of chemicals, will have different reactions with the soil. Let's look at this group here. Where do you think these are going to go? This group here, where do you think these are going to go? Clay or the organic matter? Take a look at what it is. Where do you think? Put it in the chat. Couple people. Where do you think it's going to go? Let's see here. Organic. Organic is correct. Yes, organic, because clay is silicon and oxygen. Awesome. Very good. Organic. All right. Let's find another one. How about this group? Look at the functional. Look at these functions on here. Where do you think these are going to stick? Let's see up here. Awesome, clay. Awesome. It's going to get more associated with the clay for two reasons. One, though it has some organic charge on it, because they're small molecules. So these are larger and mainly organic, but these are smaller, so they can attach to the clays. Very good, very good. Good thinking. All right. All right, so let's move on. I need to take all this off. So how is this relevant to communities? When you put contaminated soil, stop that, oh, come on, great. All right, so when you put a contaminant like lead in a community that doesn't have the money to repaint the house annually, the houses are not in repair, so old paint is stripping off. The house was already built prior to 1978 when they banned lead in paint. They are near a traffic route, a major traffic route. You and I know that, you know, going to Chicago, you hit 94 and you've got communities on the sides of 94. Those are major traffic ways. And all of them are putting lead out into the atmosphere. That lead then comes down in the rain or any precipitation, snow or hail, and that drops into the soil. So those communities often have higher lead levels in their soils. And then they don't have grocery stores. So they may do an urban garden. They're trying to do the urban garden, but the soil is contaminated. So their leafy vegetables get contaminated. The soil comes inside with the homes. All right. So we've got to think it's a holistic picture when we think of the chemistry and environmental justice. All right. Got only a few more minutes and I want to leave time for questions. So I'm going to leave this slide alone. It talks about how things move between two things in the soil. So if it prefers organics, it will stay, as we said, with the organics. And if it prefers water, it will go towards the water in the soil. And what we call partitioning between organics and water is determined by the chemistry of the soil and the chemistry of the contaminant. All right. And we talked a little bit about the chemistry of the soil. All right. So I'm going to do one quick activity and just click on this link. I'm going to come out of this. Oh, screen sharing has stopped. All right.
Hold on.
It's okay. So I'm going to put in the chat this link and I want you guys to go to that link and you'll see some questions in there. Click on the, so once you have it open, let me know. All right, I'm hearing some stuff. And once you get in there, you should be able to add, thank you, Desmond, add by clicking on this positive here. So what is the main contaminant we talked about today? Where's the contaminant located? Describe an EJ community. Why are things an issue of environmental justice? And we didn't talk about the video, so because we're out of time. So just go ahead and click on this here and type inside there whatever you want to type. All right, so let's see. You guys have it? Okay, we don't have a lot of time, so let me see. It'll show up on mine oh, there it is I see. I took it to, okay, sorry. Let's give it to everybody. Don't know why I did that. There we go. All right.
There's the link.
Thank you, Sean, for letting me know. All right, so you guys go ahead and start adding your ideas in there. Awesome, good. We talked about lead. You see that little plus? If more of you think it's the same, just click that. So I think it's the same, so I'm gonna click it. Yep, great, awesome, great. Move to the right, layer of soil, good. A layer of soil, good. Not a layer of soil, but the A layer, good, good, very good. Yeah, I agree with that, so I'm gonna click that. Nice. All right. So what kind of communities were we talking about? Paint and soil. Good. Very good. All right. Why is this an issue of EJ? Very good. Very good. Low income economic, right? Low income. Yep. I'm gonna click that. Yep, I agree. Very good. Keep going. Let's see here. Scroll down. Why is this an issue of EJ? The environment is hurting people and animals. Good. And I'll also, good. Don't forget, I'm going to add something here, compounding of issues. Richer communities don't have to tend to problems like this. So there's a dependency. That's a great word. Dependency. Discrepancy, sorry, discrepancy. Because everybody preserves equal environment, yes. Right, so we have compounding of issues, lead hurts stuff and things. All right. I would call a professional, okay. That is true, yes. Any lead renovation must be done by a certified lead professional. Very good, and that's the law. Very good, very good. Just a couple more seconds. I would try to help by properly remove the contaminant and continue to help those affected by giving other options for improved food, improved access, reducing the traffic flow during that community. Talk with local government. That's a huge one. And most people forget the local government has some power to make zoning changes. Good. Inform the community of the dangers. Awesome. These are great ideas. Great ideas. Spread information. Information is power. Knowledge is power. Awesome. Why didn't that? Awesome. All right. So I'm going to stop sharing. You guys did an amazing job. Thank you so much for having me today. I see that our time is up, but you guys did a great job. So I'm going to pass this back on to your teacher. Thank you for your attention. And Dr. Murray, I'm going to pass it back to you.
Okay. Does anyone have questions? Any questions?
You're welcome, Robert.
No, no. I have a question. So because I know sometimes people use the term topsoil. So for you, that refers to the 0 and the A, is that?
Yes, because
right?
Technically topsoil is the top 6 to 12 inches, and its A layer is usually the top 6 layers. So yes, it incorporates the A and some of the B.
Okay, all right, that sounds good. Okay, thanks again very much. And
One quick question. I have two questions in the chat. In
Mhm.
communities in Chicago and Detroit, I know they have a lot of urban farming popping up. How do they know the produce is safe to eat? And that's important. And that's where your local government, you have some of the folks on who will be coming into your class are from the ATSDR and the CDC. They work with communities to measure any contaminants in their soil. So you can go to your local health department and ask them to test your soils before planting in it. But one of you made the mention that letting people know, that's the key right there. Because if people don't know to go get their soil tested, they don't. So that's a really good question there. And could phytoremediation help remove lead from soil? That's awesome. Yes, phytoremediation can, in some cases, be used. It's not a very effective, but people are working to find plants that can remove lead and other contaminants from soil. Awesome bringing that up. That's cool. Good questions, guys.
Okay, thank you very much.
You're welcome. Thank you, guys, and have a great weekend.
Okay, thanks.
Okay. You're
Bye-bye.
welcome. Bye-bye.